Let's dive into Wasm. So first we'll have a quick summary of why is it or history. So this is not a complete history because there's some other details, but this is one particular path which contributed to the production or invention of Wasm. So in the beginning was JavaScript, which we know and love and or hate. And obviously that invented in the 90s. Then in about 2008, the V8 engine was created. And the key thing here was that it was a way to run JavaScript reasonably fast. It did things like having a separate parallel non-JavaScript model of the JavaScript, which it actually optimized, and it would like de-optimize that. So this is the point at which JavaScript became not necessarily slow. And then you had people started having some quite wacky ideas a few years later, one of which was Inscription. So Inscription can be thought of as a compiler backend that is targeting JavaScript as a machine or as an output of the compiler. So this was a proof of concept that then turned out not to actually be quite as bad as you might think, partly because things like V8 could take that JavaScript and then turn it back into machine code. But there were still some things that weren't perfect about it. So Wasm.js was an attempt to have a subset of JavaScript, a successful attempt, which encoded implicitly things like this is an int, because like JavaScript doesn't have proper ints, which then allowed the JIT paths to be more consistently hit. So you can think of it as a way of, you've got this fuzzy thing in the middle, which is JavaScript. You've got the intent at the top, which is, say, compiling a C program. You've got the intent to run it efficiently, and this is a way to try and get around the fact that JavaScript was in the middle by having a subset of JavaScript. And then the kind of obvious and retrospective thing is like, can we do this a bit better? And one of the key things about this that is pointed out in a few different talks is that this was actually quite a good combination of different browser vendors effectively getting together to say, can we do this a bit better? So it was announced in 2015, but then the first browser support that I could see was on Safari in 2017. And then the spec pub was published by WCC in 2018, and then it's grown from there. And if you look at like things like caniuse.com, then Wasm in the basic version is supported in all major browsers as a standard thing, which is no small achievement. So that's kind of like the plot history. What makes it interesting? So the interesting is partly because it comes from Webland, it's kind of born paranoid. So rather than being an open machine format, which then has to be constrained, it starts off in a context where it has to be secure. It's not just the browser, and we might touch on this later on, is that it's not, so there's Wasm and there's things like WASI, which is a system interface. So you can totally use Wasm to run a machine that's not your browser. And there's also things like nano processors, which CDN vendors can use to actually run Wasm in the CDN as a tiny process. So Wasm is not restricted to running a browser. It's small, it's fast. Probably won't go too much into that. And also it's portable. So you start getting these multiplier effects because you can write something and have it run in lots of different places. How does Rust come into this? So one of the constraints of Wasm version 1 is that it doesn't have any GC, there's no threads, so there's only a subset of languages that you can meaningfully, easily target to Wasm. There's plans in the work to add GC, add threads, which will open it up to more languages, but right now it's limited to things that can run without GC and without threads. One question is, why not C? And I think probably this audience probably has the answer to that question, because like, yeah, you could write in C to Wasm, but that's writing in C. So then one of the obvious replacements is, okay, can we target Wasm as just another machine and program in Rust? And no small part of the value of Rust is the fact that the community has a very positive attitude to including other things. So Wasm bindgen came out of bindgen, which was used to interact with C. So there's lots of tool support in Rust for Wasm. And even if Rust wasn't a good technical choice, it's a good community choice because there's lots of tools supporting what you want to do. Okay, so that's the end of the quick intro.